talking about properties of limits. Okay, so we're going to assume two things when we're talking about these. Number one, that the limit of the f function is called L, right? That's the number, the real number L, that the f function is going to be going to. And the g function is going to m. Okay, so it says express the following limits in terms of L and m. L is the limit of the f function, and m is the limit of the g function. Okay, so here are some properties that we're going to use every time we're talking about limits. Okay, number one, the limit of a sum. So what we can do is we can split this into taking the limit of the first function, right, as x goes to a, very formal, and add it to the limit of the second function. Okay, so the limit of a sum, right, this is a sum, the limit of a sum is the sum of the limits. Okay, so if you're taking the limit of two functions that are added together, you can split them apart and take the limit of each of them separately. So from up above, the limit of f is known as L, and the limit of g is known as m. Okay, so if you're taking the limit of a sum of two functions, that's the same as adding their limits individually together. Okay, the limit of a sum is the sum of their limits. So same thing for subtraction. Okay, if we are subtracting two limits, that's the same as taking the limit of the first function and subtracting the limit of the second function. Okay, and of course as x goes to a. So if we have a limit of a difference, and difference is subtraction, that's the same as the difference of their limits. So just if you know their limits, you simply subtract the two from each other, and that is how you get your answer, right? This is a property. So let's jump down to 4 since we're looking at it right now. The limit of a product. Guess what we're going to do here, kids? We're going to take the limit of each of them separately and multiply them together. So the limit of a product is the product of their limits. So L times m. The limit of f times the limit of g. Okay, so it's handy sometimes to be able to split, right, your function that you're given into maybe two different functions. It might be more understandable to do it that way. So if you can take your one function and split it into two, then maybe we're able to find the limit of each of them separately, whereas trying to find the limit of the entire function together as one might be fairly complicated. Okay, so we have these properties that allow us to deal with that kind of complication separately. So this is kind of what we were doing with the trig ones, right? We had a multiplier of a function, and we took that multiplier outside of our function, and we, in fact, at the end, multiplied the number times the limit at that function. Okay, so if we have a constant multiplier, and we call that constant c, okay, the limit of that, right, if every number, right, if every one of your terms of your function has a certain number and you can factor that out, then you simply multiply that together. And then the last one, the limit of a constant function is that constant function. Whatever that number happens to be here is the same as the limit there. Okay, and then our last one over here looks like if we have a product, that is essentially if we take the limit, okay, it's like taking the whole entire limit. So you take the limit of your function and you raise it to that p power. Okay, so these are your properties of your limits, right? Adding limits together, subtracting limits, multiplying limits, dividing limits. a scalar multiplication, raising it to a power, or the limit of a constant is a constant. Okay, so we'll use these once in a while when we're trying to simplify our limits. If the limit is fairly complicated to begin with, we'll apply these. So let's look at some things here, some problems. Here we have two graphs. We have the graph of a function I'm calling f on the left, and we have a graph of a function I'm calling g on the right. Okay, and we're going to try and find the limits using the limit properties. So let's see, the first one says, what is the limit as x approaches 2 from the left? As x approaches 2 from the left. So looking at f, what is the limit as x approaches 2 from the left for f? Right, so as you go from left to right, what is the y value that graph is approaching? 3. And if you ask me, it's probably positive 3. Okay, from the left, the graph approaches positive 3. So how about from the g? As x approaches 2 from the left, what is the y value that the graph is approaching? Looks like positive 1. So 3 plus 1, this sum of our limits would be 4. Okay, so we're looking at getting limits from a graph and then applying those properties that we just talked about. So now we're looking at negative 1. As x approaches negative 1, right? As x approaches negative 1 on your f graph, let's see, negative 1 is going in this direction and this direction. So when x is negative 1, y is 1, 2, 3, 4, 5, 6, negative 6.
Oh, so you plug a negative 6 into the...
So negative 6 is the limit of f. And what is the limit of g at negative 1?
Negative 1, it's negative 1 as well.
Negative 1, the y value is negative 1. So 2 times negative 6 is negative 12. Negative 3 times negative 1 is plus 3. So negative 12 plus 3 is negative 9. Okay, so if we're given a graph, we get the value, the y value of the limits from your graph itself. Okay, and then we apply the properties that we need to apply. So let's look at the third one. The limit as x approaches negative 3 of f of x minus g of x. So at negative 3, what is f doing at negative 3? It looks like it's going towards negative 2, right? That's the y value of the whole,
Yeah.
right? So the whole is okay. The limit does exist at a whole, so that's negative 2. Minus, let's look at g. As g approaches negative 3. Here's negative 3. And what do we notice? That there is an asymptote.
So it doesn't exist.
So at 3, the limit does not exist. So the whole entire limit does not exist. And sorry I wrote equals. Not equals. The limit itself does not exist. Okay? Because there is a vertical asymptote at g of 3. Or rather, g of negative 3. Okay, so at negative 3, the limit does not exist. So the difference of these limits would not exist because one of them does not exist. Okay? So when we're trying to find out what these properties are, we're looking at the graph and we're finding the x and the y values, and we are performing those operations on them. So here's all of them done. Remember, whenever we're trying to find a limit, you're either looking exactly what is the y value at that point, or if there's a plus or a minus, you're looking at from the left side for a minus and coming from the right side for a plus. Okay, so it's handy to use these properties when we need to simplify our function so that we can find the limit of something that might be really tough.